Hi everybody, I'm Mary from the iGEM Illinois team, and I've been working on our phylogenetics portion of our project. I thought it was interesting to create a tutorial for anyone interested in learning how to create a NextStrain build, and I'll be walking through the Zika tutorial. For more documentation, you can go to the NextStrain website to reference that. To start, you will need Agar and Auspice installed, as well as the NextStrain CLI tool. So you can go to nextstrain.org in order to get installation instructions for that. And once you have that setup done, the kind of typical steps that are required are preparing the pathogen sequences and metadata, aligning the sequences, constructing a phylogeny from aligned sequences, annotating the phylogeny, and then finally exporting the phylogeny and the metadata into a readable format. So first, I'm just cloning the Zika pathogen build, the GitHub repository for it, which includes the example data and the pathogen build script. So we won't actually need to manually go through each command because the pathogen build script will go ahead and automate that. Navigate to the Zika tutorial folder, and then make sure that you're in the NextStrain environment by typing conda activate NextStrain. And then I went ahead and ran the snakemake command, which when you have Agar and Auspice installed, makes the pathogen build really easy to run because it automates pathogen builds with a snake file that is shown in the Zika repository that we downloaded. And for our viralizer project, we did create a snake file. So that's definitely something that's really helpful to run the pathogen build in an automated manner rather than performing each command in the command line. So now I'm going to go ahead and visualize the results, which I started Auspice to view the dataset in the Zika build output directory, and then you go ahead and navigate to this local host within your browser in order to view the results. So I went ahead and I clicked on the Zika dataset, and here is the outputted tree. You can see it's color-coded by country, and I'm going ahead and selecting a certain date range, which will impact the amount of data that's shown and filter as well the data that's shown geographically on the map. So I went ahead and pressed play so that I could view the transmission over time. You can go ahead and look at each branch in order to see the divergence, the specific nucleotide and amino acid mutations as you kind of go through each branch of the tree. Another interesting factor is that you can make the branch length determined by the divergence, which is just another interesting way of displaying your data.